The event began with what appeared to be an ordinary observation. A faint white dot was spotted near Jupiter in the sky above the Atacama Desert in Chile. Initially, it was classified as one of the many blurry dots in the sky. However, unlike other celestial bodies in the solar system, this object did not orbit the Sun, but instead moved inward along a straight and rapid trajectory. Within hours, astronomers realized that this anomalous phenomenon bore striking similarities to the only two previously confirmed cases in history: the 2017 Oumuamua, and the 2019 Borisov. This would become the third known interstellar object, designated 3I/ATLAS, the third interstellar object discovered by the ATLAS survey. Its approach, speed, brightness, and orbit were markedly different from previous visitors: faster than Oumuamua, brighter than Borisov, and entering the planetary plane at a steep angle. The first definitive detection did not come from a national space agency, but from New Zealand amateur astronomer Sam Dean. He used a simple reflecting telescope to capture an unusually moving bright spot and reported it to the ATLAS network, which monitors potential collision threats. Professional observatories quickly confirmed that the object was not an asteroid. Its straight trajectory and stable, non-rotating signal definitively ruled out this possibility. NASA's Jet Propulsion Laboratory, JPL, confirmed that the object was of interstellar origin, coming from beyond the Kuiper Belt. Observatories around the world, including Chile, Hawaii, South Africa, and Europe, adjusted their observations to focus on it. Even the James Webb Space Telescope was assigned to observe it during a brief window of opportunity. Early data has revealed unusual characteristics. Composition: a mixture of silicate ice and dark metallic material, possibly magnetic. Orbit: directly aligned with Earth's orbit rather than a random flyby. Structural stability: unlike most interstellar objects, it has not disintegrated. Initially, 3I/ATLAS appeared to have a slender shape similar to Oumuamua. However, as more images were transmitted, its shape became irregular. The Very Large Telescope, VLT, in Chile, observed a narrow, sharp blade. The Pan-STARRS program in Hawaii detected a curved arc without a central mass. Images from the James Webb Telescope suggest a segmented structure, multiple synchronously moving parts rather than broken fragments. Infrared scans showed that the edges were warmer than the center, suggesting active thermal radiation rather than passive absorption of sunlight. This implies thermal regulation or energy generation, extremely unusual for natural objects. Light curve data showed that the brightness pulse intervals were consistent with prime numbers: 11, 13, 17 seconds. Such patterns are not random rotation artifacts, suggesting possible artificial modulation. By mid-July, radio telescope arrays detected a hole in the electromagnetic spectrum around the object, a silent gap at a frequency of 4.83 GHz, which is used for deep space probe communications. Unlike a static absence, this gap exhibits modulation characteristics, as if the absence of the signal itself were structured data. On July 21st, the Allen Telescope Array detected a short pulse in this frequency band: 3 bursts, followed by 2, then 5, perfectly matching the prime number pattern in the light curve. This is the first confirmed interstellar signal in human history, despite its extremely short duration and low power. NASA, ESA, China's Deep Space Center, and India's ISRO all mobilized resources to point toward 3I/ATLAS. The Deep Space Network repositioned antennas. The Madrid base in Spain began mirroring the pulse frequency band, and the Jammusi station in China joined the monitoring effort. No public announcement was made until an amateur radio enthusiast in Nevada received the same 325 pulse and uploaded it to the internet. The post quickly went viral, forcing the media and government to acknowledge the phenomenon. Public disclosure shifted the narrative from curiosity to urgency. The use of a man-made frequency suggested intent, possibly a greeting, or possibly a probe. Thermal imaging from Kyoto University recorded a sudden 7-second burst of heat radiation from the outer edge of 3I/ Atlas. Days later, NASA confirmed that the shape had changed. Asymmetrical structures were visible in both optical and infrared views. Slow heartbeat. Like thermal pulses began radiating from the interior, and high-exposure composite images revealed long, narrow, angled surface structures. Independent confirmations from multiple observation stations ruled out the possibility of image artifacts. Natural celestial bodies do not reorient, adjust their trajectories, or form structural features during flight. Theories shifted toward an artificial origin, possibly a probe or spacecraft. The object's steep trajectory means it will pass behind the Sun from Earth's perspective in late October. The period before perihelion is the optimal observation window, as it will be closest to the Sun and the inner solar system before disappearing from view. International collaboration is urgently underway. Japan has adjusted its lunar infrared observation stations. France has launched high-altitude balloons to avoid atmospheric distortion. The European Southern Observatory, ESO, in Chile, has prioritized top-tier telescope observation time. NASA's Deep Space Network, DSN, has committed to ongoing radar scans, despite extremely low return probabilities. The urgency is clear. Once it enters the Sun's shadow, it will remain invisible until early December, by which point temperatures will be lower, brightness dimmer, and distances greater. Spectral analysis of its coma, the vapor cloud escaping from its surface, revealed familiar comet materials: water ice, carbon monoxide, cyanide, and organic compounds. This discovery was surprising. Scientists had expected comets from other galaxies to exhibit alien chemical characteristics, but 3I/ATLAS's composition is highly similar to that of local comets. Two unsettling possibilities emerged. Chemical universality. Planetary systems within the Milky Way may produce similar chemical compositions, suggesting that the building blocks of life could be widespread. Intentional mimicry. The object may be masking its true composition to appear familiar. Additionally, an unknown molecule not listed in chemical catalogs appeared in the readings, sparking speculation about encoded chemistry as a form of information transmission. By early December, after the solar conjunction, 3I/Atlas reappeared, fainter, with a thinner coma, and rapidly moved away. Its orbit was never gravitationally captured. It simply passed through the solar system. Traveling at approximately 70 kilometers per second, it will exit Pluto's orbit around 2027 and vanish into interstellar space with no return trajectory. Its brief appearance left more questions. Was it a lifeless fragment, an autonomous probe, or an occupied object? Was the signal sent intentionally? Were the molecules a deliberate communication signal? With the discovery of Oumuamua, 2017, Borisov, 2019, and 3I/Atlas, 2025, humans have observed 3 interstellar objects in less than a decade. Prior to 2017, no interstellar objects had ever been recorded. Possible explanations: improvements in detection technology, especially wide-field sky surveys. We are passing through a region of the Milky Way with a higher density of debris. The timing is not random. The arrival of these objects aligns with our ability to detect and study them. The final theory suggests intentionality. We are being observed during the first era in which we are capable of detecting such objects. Chile's Rubin Observatory is set to deploy a 3.2 billion pixel camera that will scan the entire visible sky every few nights, greatly increasing detection rates. Early tests have already identified over 2,100 new asteroids in just a few hours. Once operational, it may detect interstellar objects before they arrive. buying time for interception missions. This raises a larger question. If future detections confirm a pattern, and one day visitors slow down, what happens next? 3. ATLAS could be a comet from another star system, or a completely different celestial object. Its thermal radiation, shape changes, deliberate frequency use, and prime number pattern remain unexplained. If natural, this suggests that the chemical components necessary for life are universal. If artificial, it means that contact has already begun, not yet in the form of language, but through mathematics, physics, and chemistry. The core dilemma: should we actively seek out the next one, or wait for the next one to seek us out?